Hey guys, welcome back to Math from My Desk. And in today's video, we're going to be covering subtopic 1.2 of IB Math AA and AI, both SL and HL, which is arithmetic, sequences, and series. A quick disclaimer before we start. So this content is provided for educational purposes only. This channel is not affiliated with or endorsed with the International Baccalaureate Organization. IB is a registered trademark of the IBO. Okay, so what is a sequence? So a sequence is essentially an ordered list of numbers, and each number in a sequence is called a term. So for example, here we have a sequence which an ordered list of numbers where we have 2, 5, 8, and 11, and each of these is called a term. So 2 would be the first term, 5 would be the second term, 8 would be the third, 11 would be the fourth. So we usually label terms with this notation right here. So u sub 1, u sub 2, u sub 3, etc. And this is how the IB does it. So this is how you'll see it show up in your paper 1s and paper 2s. So arithmetic sequences. So an arithmetic sequence is a sequence where the difference between consecutive terms is constant. So here between 2 and 5, you have to add 3. So that's the difference of positive 3. Between 5 and 8, you add positive 3. Between 8 and 11, you also add positive 3. So the difference between each consecutive term is the same. This makes this sequence an arithmetic one. So this is how you can define this. In this sequence right here, we have between 2 and 4, we add 2. Between 4 and 8, we add 4. And between 8 and 16, we add 8. Since the difference between the consecutive terms is not constant, this sequence is not arithmetic. So if the difference between consecutive terms is not constant, the sequence is not arithmetic. So that is what is shown here in this example. The common difference. So the common difference D is the amount added to each term to get the next term. So in here, in this sequence, the common difference, so the difference between consecutive terms, 4 and 9 is 5. Between 9 and 14, it is also 5. And between 14 and 19, it is 5. So this tells us that the common difference, D, is equal to 5. This is what is shown here. All right. In this sequence right here, this shows that common difference can also be negative. So between 20 and 15, to move from 20 to 15, you have to subtract 5. From 15 to 10, you also subtract 5. From 10 to 5, you subtract 5. And so this gives you a common difference of negative 5. 15 minus 20 is negative 5. So always check at least 3 times before assuming D. So don't stop at calculating the first common difference or even the second common difference. You want to go to the third because sometimes you can get duped. So for example, in this sequence, the common difference between 2 and 6, or the difference between 2 and 6 is 4. Between 6 and 10 is 4. So you might want to stop here in an exam and just say that D equals 4. However, this would be wrong because if you go just one more step, the difference between 10 and 15, that is 5. So this tells us that that there is no common difference in the sequence, and therefore the sequence is not arithmetic. So you always want to go at least 3 times before making sure before you write your D value. So here is the nth term formula, and what this formula does is it basically gives you well, it's in the name, the nth term in a sequence. So u sub n right here, that would be the nth term. U1 is the first term, n minus 1, that is the number of the term, the number of the term you want, minus 1, times D, which is the common difference. And this formula right here is in the formula booklet, so you do not need to memorize this. So here we have an example, so 7, 11, and 15. So U1 would be 7, because that is the first term. D would be 4, because to go from 7 to 11, you have to add 4. To go from 11 to 15, you also have to add 4. And so now what we do is, let me go back. Now what we do is we simply apply the formula. The formula was UN is equal to u1 plus n minus 1 times d. And say we wanted to find the ninth term of this sequence. U sub 9 would be equal to 7 plus 9 minus 1 times 4. So 7 plus 8 times 4, 7 plus 32, which is equal to 39. So the ninth term of this sequence would be 39. Now we move on to series. So a series is essentially the sum of the terms in a sequence. So this right here is a sequence, 3, 7, 11, and 15. A series would be adding the terms in the sequence. So that would be 3 plus 7 plus 11 plus 15, etc. The sum of the first n terms formula right here, so this right here gives you the sum of an arithmetic sequence. And these two formulas are the same. Actually, this formula is just a more detailed version of the second formula, because remember u sub n, that is u1 plus n minus 1 times d. So all you do is make this 2u1 plus n minus 1 times d, and it gives you this formula right here with n over 2, obviously. And these two formulas are in your formula booklet, so you do not need to memorize them. And once again, S sub n, that is the sum, n, that is how many terms you're adding up, u sub 1 is the first term, and d is the common difference. So, for example, let's say you have a sequence 4, 7, 10. U sub 1, that would be 4. The common difference to go from 4 to 7, that's 3. 7 to 10, that's 3. So d is equal to 3. And then here you simply apply the formula. So you have S sub n is equal to n over 2 times 2 times u sub 1 plus n minus 1 d. And then you essentially plug in your terms. So n is 15, u1 is 4, d is 3. And after you do the arithmetic, you end up with the final answer, 375. Okay, now we move on to sigma notation. So sigma notation is essentially a compact way of writing the sum of the terms of a sequence. And the symbol sigma basically means to add up. So it means to sum. So here we have sigma notation more specified. So usually at the bottom right here, so that is the starting value, and then what you have on top of the sigma notation, that would be the ending value. So you go from, for example, you sum from the first term to the fourth term in this case, and here that would give you the formula, the general formula. So for example, say you have the sum from n equals 1 to 8 of 5 plus 2 times n minus 1. So what this is telling you is to sum all the terms from u1 to u8. So this is what this tells you, and this gives you the formula for how to find each term. So to find u1, that would be 5 plus 2 times 1 minus 1. To find u2, that would be 5 plus 2 times 2 minus 1, etc. All right, so on sigma notation for the IB exam, you do have to be familiar with the notation, so know what it is asking you to do. So you also have to recognize the sigma notation always represents a series and not a sequence. And you have to be able to identify key elements from an expression with sigma notation. So these key elements are u1, d, and un, for example. Real-life applications of arithmetic sequences and series. So the big one that IB wants you to know is simple interest. So first of all, what is interest? Interest is basically the extra money that is earned or paid when money is invested or borrowed, respectively. So simple interest is interest that is calculated only on the original amounts. So you do not compound that interest up. Compound interest is actually its own separate topic that we're going to cover in its own video. So an example of simple interests, an investment of $2,000 earns $120 simple interest per year. So the amounts at the end of each year, that would be 2,000, and then a common difference of 120. So you add 120 each time. And so this gives you the general formula for the nth term, 2,000 plus n minus 1 times 120. So modeling and predictions using arithmetic sequences. You have to know that real life data is often approximately arithmetic and most often not perfectly arithmetic. You can always estimate the common difference in certain situations like annual savings uh, if the common difference is roughly the same. So you have to know for the IB how to average common difference and then how to calculate for a term or a sum based on that average. So this is directly from the IB syllabus guide for both AA and AI, and it shows clearly students will need to approximate common differences. So this is something which you have to know. This is a quick note. I will be making a video soon on how to use a graph and display calculator for sequences and series. I am just waiting to upload my geometric sequences and series video to then be able to make that video. All right, so now we have a quick TOK thought. So this question was directly from the syllabus guide for topic 1.2. Is all knowledge concerned with identification and use of patterns? Consider Fibonacci numbers and connections with the golden ratio. So here is a paragraph of what DeepSeek and AI gave me as an answer to this question, and I'm going to let you think about it. All right, thank you guys for watching. Please like and subscribe, and I'll see you soon for another video on this IB Math series.